NCERT Class 12th Physics Chapter 1 Exercise Problem number 1. The problem is, what is the force between two small charged spheres having charges 2 into 10 raised to the power minus 7 Coulomb and 3 into 10 raised to the power minus 7 Coulomb, separated by a distance of 30 centimeters in air? We have to find force between two charged spheres, so we will use Coulomb's law, which gives magnitude of force between two charged particles. Coulomb's law is force is equal to a constant 1 upon 4 pi epsilon naught multiplied by magnitude of the two charges q1 and q2 divided by square of the distance between them. And the force is attractive if charges are of opposite polarity. The force is repulsive if the charges are of same polarity. Here we have same polarity, so force will be repulsive. And what are the quantities known? We have q1 is equal to 2 into 10 raised to the power minus 7 Coulomb. q2 is equal to 3 into 10 raised to the power minus 7 Coulomb, and the distance between them r is 30 centimeters. Before using the values in the formula, first thing we have to follow is a consistent system of units. In this class and for our physics in class 12th, we will use SI units wherever possible. So for this problem, convert all the quantities given into SI units. You have q1 and q2 both in SI units. R is in centimeters, convert it into SI. It will be 30 into 10 raised to the power minus 2 meters. Now use these values in the formula. And one thing I would suggest you to follow is always use quantities with their units, because physical quantities without their units are meaningless. So whenever we will write quantities in a formula, we will write them with units. This constant 1 upon 4 pi epsilon naught has a value of 9 into 10 raised to the power 9. Its unit is Newton meter square per Coulomb square. How I got this unit for this value, for this constant quantity? Please refer the video regarding units for derived quantities. For now, just accept it. And now placing other values in the formula, charge q1 is 2 into 10 raised to the power minus 7 Coulomb. Charge q2 is 3 into 10 raised to the power minus 7 Coulomb, all divided by distance squared 30 into 10 raised to the power minus 2 meter square. Now one more thing, before doing any calculations, first solve for units. This will help you a lot. You will see it now. Let me first solve for the units. I have meter square in numerator and meter squared in denominator. Both cancel out. 2 coulombs make Coulomb square, and I have 1 Coulomb minus 2. These cancel out, and only unit left is Newton. So this quantity will have a unit of Newton. And what I was required to find, force between the charged spheres, and force we know has a unit of Newton. So our calculations are correct, means possibility of going wrong is reduced, as we are getting consistent units on left hand side and right hand side. This is the major benefit of using units with the quantities and following a consistent unit system. It will minimize errors, and if there are any errors, you will catch them earlier while solving the problem. Now solve the numerical values. there is one more trick in solving the numerical values. You have simple numbers and they are associated with the engineering term 10 raised to the power something, 10 raised to the power something. You will find such things almost everywhere in engineering calculations. So to solve such problems, first thing is to take the values before the powers of 10 and first multiply them or solve them. 9 into 2 into 3 divided by square of 30, it will be 900. Now I will write powers of 10, 10 raised to the power 9, then first charge has -7, second charge also -7. I am taking it that you know how these powers of something get added up when we are multiplying two numbers having some powers. 9 minus 7 and you have 10 raised to the power -2 squared in the denominator, that is 10 raised to the power -4 in the denominator. When it comes to the numerator it becomes +4. So simplifying this, 9 cancels out, you are left with 100 in the denominator. When it goes to numerator it becomes 10 raised to the power -2. So now we have 2 into 3 6 multiplied by 10 raised to the power 9 minus 7, that is 2 minus 7 minus 5 plus 4 minus 1 and -2 minus 3 Newton. The magnitude of force is 6 into 10 raised to the power -3 newtons, and the force is repulsive because charges are of same polarity. Answer is 6 into 10 raised to the power -3 Newton.